So here are some hypothesis testing examples that I did with my in-person class. So I have 4 examples here. I'm going to walk through each one, but the first thing that I want to start with is just kind of putting the steps to a hypothesis test. I was going to say up on the board, but on paper so that you guys can see them first. So this particular, I would suggest printing this particular document out so you can kind of follow along as notes and things like that. So let me skip to the next page where I actually have the steps. So hypothesis testing examples, and this is what we're going to do. And there's 5 steps that follow along what is in your notes, but I've abbreviated drastically. And I've also abbreviated step 1 as S1. So as we kind of go through each of the examples, you'll see my abbreviations for the various steps. So your first step is to write your hypothesis, your hypotheses, the null hypotheses, which is symbolized by H0, and the alternative hypotheses symbolized by H1. The second step is to determine which test statistic or distribution you're using. Are you going to use Z or T? Do you have a large sample or a small sample? Once you do that, you move on to step 3 and determine your critical value based on the distribution that you figured out in step 2. So you determine your T critical value or your Z critical value that you're going to compare your test statistic to determine whether or not you reject the null hypotheses. Step 4 is you actually put the numbers into the equation and do the test. And then in step 5, you make a conclusion. So let's start with the first example. A friend makes the claim that municipalities in Pennsylvania start law enforcement officers at $42,500 a year. You decide that they're wrong. You think Pennsylvania starts law enforcement officers at a different average salary than what your friend says. You select, you test this. To test this, you gather salary information for 15 municipalities and obtain the following statistics. The mean is 39,780 and the standard deviation is 2,500. Perform a hypothesis test to determine if your sample mean is truly different than the population mean. Use an alpha level of 0.05. Alright, so sorry if that was really loud. First things first, we're going to write a hypothesis test or a hypothesis statement. So here we go. I'm always going to stick with this. My null hypothesis is always that the sample mean is equal to the population mean, or mu. My alternative hypothesis, though, is something that guides us regarding our test. So I didn't say greater than or less than. The last statement is perform a hypothesis test to determine if your sample mean is truly different. So I'm not going to take a guess about whether Pennsylvania and law enforcement officers make more or less than what my friend said. I'm just going to say that they make it different. So in that sense, what I'm going to do is say mu is not equal to 42,500. So the second step is determining which distribution you're going to use. So I have an N of 15. This is a small sample, and when we have small samples, we use T. So that's very simple. The third step is figure out your critical value. So we have an alpha level of 0.05. Our N is 15. We know we're using T, so we know we have to use the degrees of freedom, which is 14 because that's N minus 1. We also know that we have a two-tailed test, which is determined by the alternative hypothesis, and that not equal to sign in the alternative hypothesis says that we have a two-tailed test. So I hit up my t-table, I go down to the degrees of freedom of 14, I go over to the significance level of 0.05 in the row that signifies that it's a two-tailed test, and I find that my critical value is 2.145. So then I draw this on a curve. So I draw out my curve, and because it's a two-tailed test, that means that 0.05 alpha level that I'm talking about says that, you guys are going to end up seeing my email, that 0.05 alpha level is means that there's about 2.5% in each of those tails. So we've got negative 1.24 on one side and positive 1.24 on the other side. This is very similar to a confidence interval. So if our t-score, and you obviously can see this in advance, if our t-score gets into the shaded regions, then we reject the null hypothesis. So we go ahead and conduct our t, and it's 39,780 minus 40,500 divided by the standard deviation of 2,500 over the square root of 15, and we ultimately end up with negative 4.21. So we plot this on our graphic above, and we see that negative 4.21 definitely makes it into the shaded region, so we know that our conclusion in step 5 is to reject the null hypothesis. Okay, let's go on to the second example, and I'm going to move a little bit faster now. So some criminologists and psychologists believe that there are key personality differences between offenders and non-offenders in regards to psychopathy, meaning psychopath serial killer types. The socialization scale has a population average of about 15. The SS was given to a sample of 177 prisoners. The average SS score for the prisoners is 27.76, with a standard deviation of 6.03. Perform a hypothesis test to determine if your sample mean is truly higher than the population mean. Use an alpha level of 0.01. And just so you know, the psychopathy scale means the higher you get, the more psychopathic you are. So obviously our prisoners are more psychopathic than the standard population. So, excuse me. Okay, so here's our example. Step 1, write your hypotheses. The null hypothesis is always going to be sample mean is equal to the population mean. There's nothing going on, there's no difference there. Now, I asked you guys to perform a hypothesis test to determine if your sample mean is truly higher than your population mean. So, first, think that my sample mean is going to be greater than 15. Then cross out that x and just insert mu, and you have the appropriate alternative hypotheses. So here we see that mu is going to be greater than 15. But like I said, remember, first think that your sample mean is equal to 15, because I'm sure is greater than 15. I'm sure that's how most of you are thinking anyway. Then cross out your sample mean and insert mu. The second step is determine what distribution you're using. We have a sample of 177. It's a large sample, so we're going to use Z. The next step is to look up your critical value. It's a one-tailed test. It's Z. Well, let me back up. It's a one-tailed test because I use the greater than sign. If I also use the less than sign, it'd be a one-tailed test as well. So one-tailed test, it's Z. Our alpha level is 0.01. On page 314, it has all of the critical values for Z. So all you have to do is go to one or two tailed test, what your alpha level is, and then go all the way over and pull that critical value. So for us, it's 2.33. So I draw my little curve down here, and it says, I draw the tail to the right because I'm testing greater than. So greater than means to the right, less than means to the left. And remember that because we're using the normal distribution, zero's in the middle. So if I can get into this shaded region, then I know that I reject the null hypothesis. So I go ahead and conduct the test right down here, and ultimately we get 27.74. It's just a coincidence that actually looks very similar to the sample mean. So we plot that on our normal curve, and obviously it got into the shaded region. It's really far out there in the tail. So we know that we reject the null hypothesis. So that's that hypothesis test. All right, so the third one. This one is particularly rife with grammatical errors, so just forgive me on this. In 2009, the average dollar amount seized by the ATF in a drug case was $75,200. In 2009, for the 14 cases they had, the Maricopa County Sheriff's average dollar amount seized in a drug case was $71,500, with a standard deviation of $3,900. Perform a hypothesis test to determine if your sample mean, Maricopa County, is truly different than the population mean, and use an alpha level of 0.01. So, first things first, null hypothesis is sample mean is equal to the population mean. And I asked you to do a hypothesis test to test if the sample mean is truly different than the population mean. So when you see different, you should know that you're writing the not equal sign in to your alternative hypothesis. So the alternative hypothesis is that the population mean is not equal to 75,200. The second thing is to determine your distribution. We have a small sample, n is 14. We're going to use t. So our third step then is to get our critical value. We have an alpha level of 0.01, n is 14. Our degrees of freedom will then be 13 because degrees of freedom is n minus 1. We have a two-tailed test because we said different or not equal to in the alternative hypothesis. So we go and we hit the t-table, we scroll down to a degrees of freedom of 13, we go over to the row that has two-tailed tests, and then to the alpha level of 0.05, and we see that our critical value is 2.160. So, because we have a two-tailed test, I draw the curve, I make one tail on the left of negative 2.160, and a positive one of 2.160, and I know that if I can get into these shaded tails, I reject the null hypothesis. So I do the test here, and I come up with negative 3.55. I stick it on our curve up here, and we see that again we made it into the shaded area, so we reject the null hypothesis in step 5. Okay, here we are, the last one. We want to see if new legislation meant to increase the sentence length for armed robberies has its intended effect. We know that the average sentence length before the new legislation took effect was 52.5. We randomly sampled 110 armed robbery cases after the new legislation took effect. The average sentence length after the legislation, not sentence, took effect was 53.2 with a standard deviation of 6. Perform a hypothesis test to determine if your sample mean is truly higher than the population mean. Use an alpha level of 0.05. Again, so step 1, null hypothesis, same stuff. The sample mean is equal to the population mean. I asked you to test if your sample mean is truly higher than your population mean. So remember, think my sample is greater than 5.25. Cross out your x bar and insert mu, so you end up with an alternative hypothesis that is mu is greater than 5.25. Determine, step 2 is determine your distribution. We have a sample size of 110, so we use z. That's easy, it's a large sample. Step 3 is find your critical values. So an alpha level of 0.05, we have a one-tailed test because I use the greater than sign in my alternative hypothesis. We go to the magical page 314 and we look up that our critical value is 1.65. So because we're testing greater than, I'm going to draw this to the right, so I know that if I can get past positive 1.65 in my test, I'm going to reject the null hypothesis. So I conduct the test down here, and I see that my end result is 1.23. Obviously, I draw this line, it's obviously crooked. This didn't make it into the shaded area. It's a little less. Remember that the center of the distribution is 0, so it's going to be somewhere here, so we didn't make it into this area. Because of that, your conclusion is fail to reject the null hypothesis. So meaning that we can't in earnest say that post-legislation sentence lengths were longer than pre-legislation. Okay, so I just wanted to quickly point out a couple of things. Questions 3 and 4 are in your book. In chapter 8, you can read through them if you want, if you need kind of more understanding and exposition on these. Additionally, these are test questions. They're not going to be on your test, but I've pulled them from previous tests, so you're going to see the kind of setup that you typically get for a test.